Okay, so this will be on special sequences and series. And remember, the sequences are separated by commas. The series are separated by plus or minus signs. Okay? One that you have probably seen before, either in math class or in biology class, is the Fibonacci sequence. Have you heard of that one before? Yeah. The Fibonacci sequence always starts out 1, 1. And you add the two previous numbers together to get 2. Add the two previous numbers, add the 1 and the 2 to get 3. Add the 2 and the 3 to get 5, 8, 13, 21. Add the 21 and the 13 to get 34. Add the 21 and 34 to get 55, and so on. That is a special sequence that is seen in nature. For example, if you've ever looked at one of those large sunflower heads, and if you count the spirals going in one direction, they will usually be like 55. The spirals going in the other direction will be like 34. Okay, you can look at spirals like on pineapples. You can look at all kinds of, but this sequence will appear a lot in nature. If you go back to the Pascal's triangle that we did the other day, if you look at that triangle, remember that triangle always starts out with 3 1s. Okay, if you look at that and look at some of the diagonals, the 1, okay, the 1 and 1's 2, the 1 and 2's 3, and if you keep going down here, you'll see the Fibonacci sequence appears in Pascal's triangle. Okay. Another famous series is for E. And this is probably the first time that you've talked about E. E is the base for natural logarithms. And this one is, E is named after the mathematician Euler. Looks like Euler, but you pronounce it Euler. Okay, and we're going to look at e to the first. E to the first comes from the series 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial, and it continues in that pattern, 1 over 4 factorial plus, and then show a dot 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 to show it continues, plus 1 over n factorial, and then plus dot dot dot. Okay, and that series is approximately, now if you ever forget, what does E equal? It's just like pi. We remember pi, it's rounded to 3.14. E, what does that equal? On your calculators, you have the value for E. If you look on the left-hand column down, there's an ln for natural logs. And we'll talk more about logarithms tomorrow. But right above that, the e to the x. So do second function, okay, and it should put e to what? Going to put e and then raise it to the, okay, and let's just put in 1. E to the first power is approximately 2.718, okay? That's the base for natural logarithms, e to the first. So if you ever forget, you can always get it on your calculator. That's e to the first power. Okay, now the author goes through in this section the exponential series. Okay, instead of e to the first, let's look at e to the x power. Okay, e to the x power. And these, I'm going to give you some of these sigma notations just so you have them in your notes. And then I'll show you what we're going to do for the problems. E to the x power is the sum of, up in the numerator, x to the n power over n factorial, and then it's as from n equals 0 to infinity. Okay? If we expanded that out, it would be 1 plus x squared over 2 factorial plus x to the third over 3 factorial plus x to the fourth over 4 factorial, and then put a plus and a dot 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 to show that that continues on. Okay, so this is the formula that we're going to look at for the e to the x power. Okay? The author will give you directions like this. Use the first 4 terms, or first 5 terms. Use the first 5 terms of the exponential series use the first 5 terms of the exponential series and a calculator to approximate the value of e to the point, and they're going to give you a decimal. In this problem, we're going to do e to the 0.65 power to the nearest hundredth. So we're going to round it to the nearest hundredth. Okay? So we're going to use this formula, e to the x equals 1 plus x to the second over 2 factorial plus x to the third over 3 factorial plus x to the fourth over 4 factorial. And really we ought to have that it is it's approximate. So 0.6 e to the 0.65. Now, here's the long way to do this. I could put in, for each one of these x's, I could put in 0.65. How many keystrokes is that? 0.65, 3 keystrokes. I can shorten it if I take and I store this for x, and then each time just type in an x. Okay, so we're going to take that decimal, 0.65, and we're going to store that as x. We're going to let x equal that, in other words. Okay, so on your calculator, okay, you need 0.65, and down right above the on key and the key store, STO, store that. It will always put a little right arrow on your calculator. Store that and just use the xt theta n key. Store that as x and press enter. So it should look like that on your calculator or on your screen. Okay? Okay, now we're just going to go right through and type this in. Okay? So we want 1 plus x. So I'm putting in 1 keystroke instead of 3. Okay? Plus x squared divided by, now, do I need to put in the factorial? What's 2 factorial? 2 times 1 is just 2. So I don't need that factorial. That's an extra keystroke. Plus x to the third. So x, and raise that to the third power. You can go x to the third under the math key, or you can just do x and raise it to the, use your caret symbol. X to the third power divided by 3 factorial. 3 times 2 times 1 is just 6. Okay, plus x to the fourth, and divided by 4 factorial. Yep. Okay, and then press enter. Okay, and I get 4 factorial wasn't 4 times 3 times 2. No, got to go back one. Yep. 4 times 3 times 2 times 1, 24, right? Right? Okay. Now, if you do that, like I made that mistake, so you can do second function entry. Okay? Remember, you can do second function entry, that's right above the enter key, and then just retype over it, okay? And end up with, now, don't do the whole problem and miss it because of the rounding. They want it to the nearest hundredth. So it's 1.914, so we're going to round it to 1.91, okay? And that would be your final answer, 1.91, okay? So the whole thing on this problem is store the exponent and take that out using the first 5 terms in that formula, okay? Any questions on that? Yeah. It will stay in there until you put another value in, and that won't hurt anything. Okay. You could, in the memory, clear it out. No. No. Only, and you can turn the calculator off. You could come back a year later and 0.65 is still stored in there. Okay. It's if you need to store something new, and you will in the homework. Okay. But you could, under second function memory management, delete. Okay, but I wouldn't worry about it. Okay. Okay, that is the exponential series. Okay, when they talk about the exponential series. Okay, now we're going to look at the trigonometric series. I know we haven't done much in trig yet, so but you did do trigonometry in geometry. In geometry, you should have done sine. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse. Okay, but we're going to look at it as in terms of a series. Okay, and we're going to look at it for cosine. Okay, and sine. The one thing that's different on this part, for what we're doing in geometry, you probably did it in terms of degrees, like 30 degrees, 45 degrees, 60 degrees. For what we're doing, we're going to do it in radians. So you need to check your mode on your calculator and make sure you are in what they call radian mode. And we'll get into that more in trig. So just do the mode key up by the second function key and make sure this is in radian mode. Okay, it has to be dark. Okay. Okay. For cosine and the angle x. Okay, and I'm going to give you the summation formula for it. We're not really doing that much with the summation formulas, but just so you know, they can be written as a summation. Up in the numerator, it's -1 to the n power x to the 2n power, and it's all over 2n, that quantity, factorial. And n goes from 0 to infinity. Okay? If we expand that out and simplify it, the series is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus x to the 8th over 8 factorial, and then minus, and then dot, dot, dot. Notice the author's going 5 terms on all these formulas. Okay? And that's what we'll use for doing cosine. For sine, same thing, you still want to be in radians. Sine, the formula for the summation is the summation up in the numerator. It's -1 to the n power x to the 2n plus 1 power. It's all over the quantity 2n plus 1, that quantity factorial, and n equals 0 to infinity. Okay, if we expand out the sign, the first term is an x minus x to the third over 3 factorial plus x to the fifth over 5 factorial minus x to the seventh over 7 factorial plus x to the ninth over 9 factorial. And then you need a minus and a dot dot dot. Okay? And these have to be in radians. So if they give you, like, find the sine of 5, okay, you need to make sure your calculator's in radians, and then you punch that in. Okay? Okay. So let's do one. Let's do like the sine of. Let's do the sine of 4 as an example. Okay. So we need to punch this in. The first 5 terms. The author will say use the first 5 terms of the trigonometric series. Okay. So we want to do 4. Store that as x. Okay, so 4, and hit the store key and store that as x. Okay, now you punch this in. Okay, so we're going to do 4. Oh, sorry, go back. We just need to do x. X minus x to the third divided by 3 factorials, 3 times 2 times 1, so that's just 6 plus x to the fifth divided by 5 factorial, that's 120. That's one that you really probably should memorize. Minus x to the seventh divided by, now, instead of memorizing this one, go ahead and put in 7, do the math key, left arrow once the probability, and then number 4 is the factorial key. Okay, and then plus x to the ninth, and then divided by, and then let's do 9, then the math key, left arrow to probability, and number 4. Okay, and I get a negative 0.66. They will probably on this go 4 decimal places. Let's go negative 0.6617. Okay, that's rounding it to 4 decimal places. Now, if we go back on the home screen and just do the sine of 4 radians, just do sine of 4. Okay, and the actual sine of 4 is negative 0.7568. Okay, this really should be approximately. Okay, so it's close, but not that close on this one. Okay, everybody get the idea? Okay. Okay, draw another little separator. Okay, this is another formula. Is derived by replacing the x in e to the x. So we're going to go back to that exponential series, and we're going to replace the x in this e to the x by I alpha. Everybody look up here for a minute. Alpha looks like this. Okay, it's another Greek letter, alpha. Okay. Okay, so if we take the e to the x formula that we had before and replace the x with I alpha, okay, we'd end up with 1 plus I alpha plus, up in the numerator, I alpha over, sorry, those parentheses go on top, just I alpha, that quantity squared, over 2 factorial plus the quantity I alpha cubed over 3 factorial plus I alpha to the 4th over 4 factorial plus dot dot dot. Shows that continues on. Now you have to go back and remember I. Remember I is like the square root of -1. I squared, what's I squared? -1. I cubed is like I squared times I, so that's like -I. I to the 4th is like I squared times I squared, so that's like -1 times -1 is 1. And remember, this is like a cycle. It'll go I, -1, -I, 1, and then it repeats that cycle, okay, every 4. Okay. If we simplify this formula, e to the I alpha equals 1 plus I alpha if we go I squared, alpha squared, the I squared is -1, so it's going to change that sign. It's minus alpha squared over 2 factorial. If we simplify, I to the 3rd is like -I, so it's -I alpha to the 3rd, okay, over 3 factorial. Okay, and then plus alpha to the 4th, because I to the 4th is 1 over 4 factorial plus dot dot dot. Okay. Now, if you take and regroup, okay, we're going to group every other term together. Okay, so if you regroup, e to the I alpha equals 1 minus alpha squared over 2 factorial plus alpha to the 4th over 4 factorial minus, it would go alpha to the 6th over 6 factorial, and then plus dot dot dot. Okay, and then out of, go every other term up here and factor out an I. Okay, you'd have plus I. You take an I out of this, you'd have alpha minus alpha to the 3rd over 3 factorial plus alpha to the 5th over 5 factorial minus alpha to the 7th over 7 factorial, and then plus dot dot dot. Now, if you go back and look at your notes, go back up above, what does this look like in your notes? Okay, that should look like cosine. So you have e to the I alpha equals cosine of alpha plus, then if you go back and look at your notes, what's this one look like? Sine. You still have this I in front. I sine of alpha. Okay, and this is a famous formula in math called Euler's formula. Okay. For what we're doing as far as homework, you probably won't use that formula, but you will use the others where we store the value for x and then simplify it. Okay. Okay. Okay, that's as much as we're going to cover, okay, on section 12.7. Okay. First day. We'll do more tomorrow.